Hello everyone, welcome to my YouTube channel. I am again in front of you with the lecture of class 12th. In the lecture of class 12th, today I will teach logarithmic differentiation. What is logarithmic differentiation and where it is used? Actually, when it is given as the function having variables power variable, function is equals to variables power variable is there, then you have to use the logarithmic differentiation. Or if the question is very complicated, you want to simplify it, you want to devote less time for solutions, so you have to opt logarithmic differentiation. Okay, so let's start. What is this logarithmic differentiation and how the question is done with using this logarithmic differentiation? To start, I will take the question from your exercise 5.5. This is and from your ncert book I have taken these 4 questions. See these questions. If I do the differentiation, it takes lot of time because u into v into w is there. You have to do the differentiation by the product rule. It takes a lot of time, and the error, when a question takes lot of time, then there is a possibility of errors as much as compared to the less simplification. Okay, the second question is also in the division and also in under root, and in the division there is a product form also. So it is also very not a simple question. So you have to, when you have to use a logarithmic differentiation, it become very easy. How I will solve for you? This is variables power variable. This type of question is also done by the logarithmic differentiation, and the fourth part is there are 2 parts are given and you have to use by u and v. You can do it by u and v. So how you can solve? Let's start with the question number first. How we can solve the question number first? The first question you have to take it as by log x cos x cos 2x cos 3x. Okay. Now apply log on both sides. When you apply log y is equals to log of cos x cos 2x cos 3x, right? Cos a into b, that is log a plus log b. I have told all the properties of logarithm in the previous lecture. Okay, so according to these properties, the log is equals to log cos x plus log cos 2x plus log cos 3x. Okay, here we have log y. Now differentiate with respect to x. When we have to differentiate with respect to x, it becomes 1 by y dy upon dx. Okay, and here 1 upon cos x, and the differentiation of cos is minus sine. This is minus sine x plus 1 upon cos 2x, and cos 2x differentiation is minus sine 2x, and further the differentiation of 2x is 2. Now the third one is 1 upon cos 3x, further differentiation of cos 3x is sine 3x into 3. So this is the way. Now you have to multiply with y. How? Dy upon dx is equals to y, and when you divide it, it becomes minus tan x, it becomes minus 2 tan 2x, and it becomes minus 3 tan 3x, right? Now you have to put the value of y here. What is the value of y? I will write the value of y. Cos x cos 2x cos 3x. You can take these negative common. How you can take this negative as a common factor? This is tan x plus tan 2x plus tan 3x. So this is the way to solve the differentiation by using logarithmic differentiation. Okay, so this is the way, very easy question. Now come to the second question. How we can solve the second question? That is also very simple. Let's start with the second question. Second question is very simple. Again same like by putting log. Second question, the solution of second question I will do by using logarithmic. This is second part. x minus 1, x minus 2, in the denominator x minus 3, x minus 4 and x minus 5. Under root means the power is 1 by 2. Is it right? Apply log on both sides. Log y is equals to log of whole term x minus 1, x minus 2 upon x minus 3, x minus 4, x minus 5 raised to power 1 by 2. According to the properties, this 1 by 2 powers come in front of it. According to the property, the power come in front of the logarithm. Now apply u upon v. What is the property of u upon v? That is log u minus log v. So how you can take half as a common factor? Log u minus log v. Okay. So this is now the third property which is applied in this, that is of logarithmic, that is log a into b. Log a plus log b. This is half log x minus 1 plus log x minus 2, and here all the three terms which are in positive that convert into the negative form, minus log x minus 3 minus log x minus 4 and the minus log x minus 5, and close the bracket. Now no further simplification of logarithm is possible. Now you have to do the differentiation with respect to x. Differentiation with respect to x. How you can solve? Take the differentiation with respect to x by using, how you can differentiate it? The differentiation is very simple and very easy. How to solve? Log y, that will equals to 1 by y. Okay, 1 by y dy upon dx, the differentiation of this side. Now half as it is, and the differentiation of this 1 upon x minus 1 plus 1 upon x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. So this is no need to take the LCM and further simplification, remain as it is. Take y here. We have dy upon dx is equals to y by 2 and the whole term as it is. Okay, like this as it is, you have to write the same term, no need to do further simplification. In the next step you have to put the value of y only. What is the value of y? That is x minus 1. So you have to write the values of y. What is that value? Very simple value that is given in the starting, that is y, x minus 1, x minus 2, x minus 3, x minus 4, x minus 5, and again inside the bracket we have the same term like this, x minus 2 minus 1 upon x minus 3 minus 1 upon x minus 4 minus 1 upon x minus 5. So this is the way to do the second question. Okay, now come to the third question. When variables, power variable is there, this is this contain less simplification. Okay, so I will use the logarithmic differentiation to solve. It is sure method for the variables power variable. If there is a variables power variable, so you have always used to logarithmic differentiation. The third question, y is given as log x raised to power cos x. I will write log x raised to power cos x. Now taking log on both sides. Don't be think about one log is already there. Why should we use logarithm? By using logarithm, the question become very simple and the differentiation is possible as compared to other questions. Simple, that becomes simple question. Log y and log x cos x. The property says that log of this comes forward. This log y is equals to cos x log x. How you can solve it? By taking two functions u into v. Differentiate with respect to x. When you differentiate it with respect to x, this will 1 upon y dy upon dx. It will equals to cos x. The differentiation of first function, that is 1 upon log x, and further the differentiation of interior function, that is 1 upon x plus. Now this function remain as it is, and the differentiation of cos is minus sine. So I will write minus here sine x. This is simplified and differentiation is over. Only the think about is you have to take this on right hand side. Dy upon dx is equals to y, that is cos x upon x log x minus sine x log x. This is very simple simplification. At last you have to change this y in the form of log x raised to power cos x. So this is the way to solve the logarithmic differentiation. Very easy. Now come to the fourth question. How you can solve fourth question? Question is again very simple. Very simple. You have to take u and v, two functions, because you can't take the function logarithm in the addition or subtraction form. One important thing about the logarithmic function, the y should not be in a negative form, otherwise logarithm will not be defined. Okay, if the function is in the negative form, the logarithm will not be defined. So you have to keep in your mind the function should be positive. This is the important and main point to be kept in your mind while doing logarithmic differentiation. Now come to the fourth question. Fourth question is x raised to power x minus 2 sine x. This will equals to y. But you don't want to, you will not take log both sides, because log a minus log b never be equals to log a minus log b. No, you will take it as u and it will take it, you will take it as v. How you can solve dy upon dx? If you want to differentiate, take the differentiation with respect to x, it will equals to dy upon dx. This is equation number 1. Now when you put these values in this, the differentiation of these two functions in this equation, you will get the value of dy upon dx. Now take, when v is u is equals to x raised to power x, taking log on both sides, log u is equals to log x raised to power x, log u is equals to x log x. This will equals to 1 upon u du upon dx. It will equals to u into v. X as it is 1 upon x plus log x, and x is equals to 1. X you have to take it as a two function. X as it is, differentiation is 1 upon x log x, and x is equals to 1. Now this x and x will cancel. We will have 1 upon u du upon dx is equals to, I will take this u on the right hand side. This u on the right hand side, this will u, this 1 plus log x. I will put the value du upon dx. What is the value of u? That is x raised to power x. X raised to power x 1 plus log x. Okay, now come to the next v part. V is equals to 2 sine x. So how you can differentiate? If you want to take logarithm, you can take. If you want to do it directly, you can also do it directly. How you can do it? Dy upon dx, it is equals to a raised to power x, that is a x into log 2, and the further differentiation of sine x, that is cos x. So this is the differentiation of dv upon dx. Now from put the values in equation 1. When you put the values in this equation, dy upon dx is equals to du upon dx. This is the value of du upon dx, 1 plus log x. Then minus v, that is 2 sine x log 2 cos So this is the way to solve the questions. These are the 4 questions. Now come to the next question. I will do the question number 5th for you, so that it becomes easy to understand the questions while doing the exercise. Okay. So I will do the question number 5th also. What is that question? Question number 5th is x minus x plus 3 whole square. This is x plus 3 whole square, x plus 4 whole square. This is whole cube and whole cube, x plus 5 raised to power 4. So how you can solve this question? Take it as y. Take log y is equals to log x minus 3 whole square, x plus 4 whole cube, x plus 5 raised to power 4. Okay, this is in plus. Write the properties A, B and C. Log A plus log B plus log C. Okay, now according to the next property, it comes forward. Log x plus 3 plus 3 log x plus 4 plus 4 log x plus 5. This is log y. Now, no further simplification is possible. Now, apply the differentiation. Differentiate with respect to x. When you differentiate 1 upon y, dy upon dx is equals to 2. This is 1 upon x plus 3. This is 3. This will equals to 1 upon x plus 4. It will 4 and 1 upon x plus 5. Now you can take this y on the right hand side and put the values dy upon dx. When you take it as y, so you can change this y by using their values. That is x plus 3 whole square, x plus 4 whole cube, x plus 5 raised to power 4, and inside the bracket 2 you have 2 by x plus 3, 3 by x plus 5 and 4 by x plus 5. So this is the way to solve the question by using logarithmic differentiation. Understand these questions, keep the main things in your minds, do the practice of these type of questions. Thank you.